Using the limit definition in finding the derivative of a quotient requires determining LCD. Just what would radical functions require for us to determine the derivative? Welcome to differential calculus. Let's find the derivative of the function y is equal to the root of 2x plus 5. Start by transforming x and y with the deltas, and take out the parentheses inside the radical sign and have y plus delta y is equal to the root of 2x plus 2 delta x plus 5. Next is to transpose y to the x expression, but remember that the premise has given y as the root of 2x plus 5. So we have delta y as equal to the root of 2x plus 2 delta x plus 5 minus the root of 2x plus 5. With two terms in radicals, we use conjugate. For the example, the conjugate is just the sum of the two terms, so multiply the solved function by the root of 2x plus 2 delta x plus 5 plus the root of 2x plus 5 over the same roots to keep the multiplier as 1, thus not altering anything in the function. The job of the conjugate is to eliminate the radicals from the numerator, and the concept behind it is to transform the terms into difference of two squares. That is why we use the opposite operator. So after multiplying the conjugate, we have delta y as the square of the root of 2x plus 2 delta x plus 5 minus the square of 2x plus 5, all over the root of 2x plus 2 delta x plus 5 plus the root of 2x plus 5. The square of the roots on the numerator makes it 2x plus 2 delta x plus 5 less the quantity of 2x plus 5. Distribute the minus sign to take out the parentheses and cancel out similar terms. Those are 2x and 5. Resulting to delta y as 2 delta x over the root of 2x plus 2 delta x plus 5 plus the root of 2x plus 5. The third step is to divide the function by delta x, and this step eliminates the delta x from the numerator. So the function becomes delta y over delta x as 2 over the root of 2x plus 2 delta x plus 5 plus the root of 2x plus 5. This is the transformed function that we need to take the limit with, as delta x approaches 0. With the limit of delta x, 2 delta x from the first root in the denominator is zeroed out, leaving with dy over dx as 2 over the root of 2x plus 5 plus another root of 2x plus 5. Combine the roots and have 2 over twice of the root of 2x plus 5, where the 2's cancel out, having the final derivative of y with respect to x as the reciprocal of the root of 2x plus 5. The function for the second example is y, which is equal to the root of a squared plus x squared. Again, start by adding deltas to x and y, making it y plus delta y as equal to the root of a squared plus the square of x plus delta x. There's nothing to simplify at this point, so continue the procedure by transposing y to the other end. Take note that y is equal to the root of a squared plus x squared. So delta y becomes the root of a squared plus the square of x plus delta x minus the root of a squared plus x squared. Having two roots for delta y, we multiply the function's conjugate, that is the sum of the two roots. By simplifying the numerator, we have the square of the root of a squared plus the square of x plus delta x minus the square of the root of a squared plus x squared, this time with the denominator from the conjugate. Cancel out the radicals with the squares to have a squared plus the square of x plus delta x minus a squared plus x squared. Next is to expand the square of x plus delta x and distribute the negative sign on the third term. Without any groupings, we can take out similar terms easily. They are a squared and x squared, thereby reducing the function into 2x delta x plus delta x squared over the root of a squared plus x squared plus 2x delta x plus delta x squared plus another root of a squared plus x squared. Next is to divide the function by delta x. And note that the delta x's from the numerator cancel out with the new denominator, making the function delta y over delta x as equal to 2x plus delta x over the root of a squared plus x squared plus 2x delta x plus the square of delta x plus the root of a squared plus x squared. This function is still quite long, but we still proceed with step 4, finding the limit as delta x approaches 0. The last step takes out all the delta x's from the function. So dy over dx becomes 2x over the root of a squared plus x squared plus another root of a squared plus x squared. Simplify the denominator, making it twice of the root of a squared plus x squared. Cancel 2 and have dy over dx as x over the root of a squared plus x squared. The third example has the function 3x minus the root of x. This is a different case as the radical is only on one term, but let's start just the same with the transformation of x and y. The function transforms into y plus delta y as equal to 3 times x plus delta x minus the root of x plus delta x. Next is to transpose y to the other side of the equation, not forgetting that y is 3x less the root of x. Delta y is then equal to 3x plus 3 delta x minus the root of x plus delta x minus 3x plus the root of x, where we can take out 3x. So delta y is then 3 delta x plus the root of x minus the root of x plus delta x. With 3 terms in the function, 2 have radicals but the other doesn't. What we are going to do is to group the 2 short terms together and then still multiply the conjugate, which would turn as the sum of the terms. If we simplify the product, we get the square of 3 delta x plus the root of x minus the square of the root of x plus delta x, all upon 3 delta x plus the root of x plus the root of x plus delta x. Simplify the squares to have 9 delta x squared plus 6 root of x times delta x plus x, and they are subtracted by x plus delta x. Take out x from this point and have delta y as 9 delta x squared plus 6 times the root of x with delta x minus delta x, all over 3 delta x plus the root of x plus the root of x plus delta x. The third step is to divide the function by delta x, and this will cancel some of the delta x's from the numerator. So delta y over delta x becomes 9 delta x plus 6 times root of x minus 1, all over 3 delta x plus the root of x plus the root of x plus delta x. With the function already simplified, move to the last step of finding the limit when delta x approaches 0. This step zeroes out the remaining delta x's from the function, reducing it to dy over dx as 6 root of x minus 1 all over 2 root of x, which can be further reduced to 3 minus 1 over 2 root of x.